During this lecture session, I will be taking up the few important issues related to the JIT based approaches for materials management. The first one is I will elaborate on the difference between the push and the pull systems. That is the first topic we are going to discuss. In the last lecture sessions, I have just referred to say the push system, and what we mentioned that the MRP system is based on the push system, whereas the JIT system is based on the pull system. So you must have a very clear idea about say the difference between the push and pull system. Then we are going to discuss the Kanban systems and what is a Kanban systems, and you also must know the working of a Kanban systems. How does it work? And while you implement a Kanban systems, what are the rules you have to follow for its working, and how to determine the number of Kanban. So these are the few issues we are going to discuss the next half an hour or so. Now I have already used the term called push system as well as the push or the pull system. Now what is a pull system? So a push system is essentially an MRP based production planning and inventory control systems. We have already discussed MRP in detail. So whenever you create an MRP system, it is based on a push system. In this system, the main objective is to produce two capacity. That means at any particular workstation or the work unit or a particular say machining center or at a particular facility, what is known in advance, that is its capacity. While you start producing say the producing the components or the items at that particular workstation, now if you produce as per the capacity, then essentially it is a push system. Assuming a steady demand situation, now you feel like producing up to the capacity only when you are assured of a steady demand or a fixed demand, and that is in the steady demand situation only you opt for a push system. If the demand changes quite frequently, an erratic demand pattern, push system doesn't work efficiently, because what might happen that if the demand pattern is erratic, sometimes the demand could be very low, and so under the low demand conditions, so you'll be using your resource or use your work center say underutilized. It remains underutilized, and so there could be underutilization of measures of the resources with its serious implication on financial the performance. Okay, so what will happen that if there is erratic demand pattern, then the resources which you use for production, these resources could be maybe underutilized, or in certain cases it also may be overutilized. Now both the situations, both the conditions are treated as undesirable. However, in produce to stock strategy with guaranteed demand of consumer items regularly used, okay, the push systems may be a desired alternative. That means with the produce to stock, so either today or tomorrow the stock will be sold, that is guaranteed, because but it may be in the category, the product which you are producing, that may be in the category of the essential goods, and there is a constant demand for such goods and the products. So the material and information flow process in a push system is given by this one. That means suppose there are three processes we have. So the process 1 output goes to process 2 as an input, and similarly the process 2 output goes to process 3, and the process 3 is basically maybe the last stage or the assembly stage. You get the finished product, and this is your material flow. And what is the information flow? That means the raw material you send to the process 1 along with the information that this much the raw materials has been sent for production at the process 1. So both this flow of materials or the parts and the flow of information, they are in the same direction. Okay, so you are pushing it. That means as soon as the process 1 the production is over, the output is pushed to the next stage. Is it okay? And similarly the same logic holds between process 2 and process 3. Now, so MRP system is essentially based on the push system. But if you try to adopt the JIT based production and inventory control systems, so the first thing you have to do, that is you need to convert the existing push system into pull systems. So already the circumstances may be forcing you to change the push system to the pull system. So suppose the few years back it was a steady the demand pattern. Today, because of many external reasons, suppose for the same product you are getting an erratic demand pattern. So what do? That means the few years back when there was a steady the demand the situation, it was a push system. But today under the erratic demand situations, you have no other alternative but to convert your push system to the pull systems. So that is the first preconditions you have to adopt. You have to the fulfill. So so a pull system is essentially a JIT based production and inventory control systems. Now in these systems the main objective is to produce as per the demand, assuming a highly fluctuating and erratic demand pattern. That means if you just refer to the third objective of TPS, so it talks about how to respond effectively, cost effectively to a erratic the demand situation. That means that is referred to as the change. So if you adopt the pull system in your the production systems or manufacturing systems, it becomes easier for you to adapt to or say respond to erratic demand the situation effectively. In today's context, now this is the point to be noted, many companies face a highly competitive situation wherein a steady demand of products may not be assured, even if the company's product is well known. That means the well known companies, reputed companies, internationally renowned companies, they are also facing these problems because it's we are facing a perfect competition say the situation, and the company is known, even if the company is known for its core competency in the product concerns, they also may face this sort of the problem. So this is a very common occurrence these days. Now a pull system performs very efficiently under erratic demand situation. This point already I have mentioned. The materials and information flow process in a pull system is given with this. If you look at the figure, so it represents essentially the materials and information flow process. We have already what is the materials and information flow process for a push system. Now for the pull system, what do you find over here? That means the flow of materials or the parts, this is in one direction from left to right. That means from say the upstream to the downstream process. So this is basically the upstream process, and this is basically your downstream process. So this is in this direction, whereas the information flow is in the opposite direction. That means at any point in time you must know that what is your finished goods product or finished product the demand. So during this information you get, and as per this information or so you start producing. Suppose you find that the next 1 hour the 50 units are to be produced. So this information you collect from say the downstream say the process, and as per the downstream process the requirement you start producing as you are the upstream process. Okay, so and as soon as the required quantities are manufactured or are produced, that means that the next stage is pooling the required the quantities from the preceding stage. So that's why it is referred to as a pool system. So this logic you follow at all the production stages, okay, down to the say the upstream stage. Is it okay? That is, the first stage is the raw material stage. In the typical the repetitive the manufacturing say the system. In a pool systems, items at each stage are produced as per the demand of the next downstream stage in a given period of time, that is the short term. Is it okay? And the requirements of certain items at a stage are pooled from the previous upstream stage. At each stage, manufacturing or production technology employed should be such that the production of varying amounts or the quantity is cost effective. So that is to be checked. That means what is most important is that in today's the conditions and the technologies are available these days, that suppose you produce 50 units per hour, so you get a cost, and this cost is acceptable to you. Even if you produce 150 units say the per hour, or say in 2 hours, so again the cost there could be some marginal change in the production cost as well as the product cost, but this change is minimum. So that's why this is an acceptable situation as far as the cost of production is concerned. Japanese companies use Kanban systems to control production and inventory following JIT principles using pool systems. Now we are going to discuss the Kanban system. So Kanban is a Japanese word meaning visible record. So please note down these points. So this is the Japanese word, and the equivalent English meaning in English language is visible record. Toyota developed the Kanban system. In this system, a set of cards travel between preceding and succeeding processes or the production stages, communicating what parts are needed at what quantities at the subsequent processes. That means there is a concept of internal supplier and internal customer. So at a particular stage you are producing something, and you are producing for the next stage. So obviously the next stage is your the customers, and you becomes the supplier to the next stage. So this is the basic concept, and a Kanban card is used to make for sending the items from say the preceding stage to the succeeding stage. So it is used to move materials driven by the uses of parts and to control WIP production and inventory flow. That means how many say the parts you need to send to the next stage, and this is controlled by the Kanban card, right? So the travel of say the materials either in say the raw material conditions or in semi-finished conditions. So this travel the time as well as the how much say the quantity, how many units you are the transporting from the preceding stage to the succeeding stage, these are controlled by the Kanban systems. Now there are two types of Kanbans which are commonly used. The first type is known as the withdrawal or the conveyance Kanban. The conveyance means the transporting. That means on this Kanban card, suppose certain say the number is given, say the units. So suppose the 50 units are specified for a given part. That means it means that this is an authorization, and you need to say send 50 units to say the next stage, or you need to say withdraw this amount from the preceding stage, and it must be sent to the next stage or the subsequent stage. And the next one is the production Kanban. That means as per the production Kanban say the requirements, that means the requirements are mentioned, that how many units you are supposed to produce during a specific time period. So that the number is specified, and only this number of the units you produce. So that is referred to as the production Kanban. So the primary function of a withdrawal Kanban is to pass the authorization of movement of parts from one center to another. That means from the preceding stage to the subsequent stage. The primary function of production Kanban is to release an order to the preceding process or stage to produce parts equal to the lot size specified on the card. So the lot size is mentioned for the given item. So the Kanban system is essentially a two-card system which was originally proposed. Later on, in certain under certain cases, the under certain conditions, the two-card systems can be changed to say one-card system also, but only under specific conditions. So right now we are discussing the two-card the Kanban systems. Now in JIT system, control of materials and WY inventory at the shop floor is an important consideration. The shop floor control is done by the Kanban system. The Kanban systems needs to be explained in respect of two successive successive production stages. So we'll try to explain what is a Kanban system. So the preceding stage, that is the the preceding production stage 1, and subsequent production stage 2, okay, with a stacking area. That means the intermediate stage notation is SA in between. Is it okay? The sequence of movements of Kanbans, withdrawal and production, both types, and the containers between preceding processing stages and the stacking area is presented in the figure. So I will show you the figure. The flow sequences explain the working of a typical Kanban systems. The Kanban card is attached with a container of a specified capacity, say 50 units, 100 units. When you take up numerical examples, it will be made very, very clear in terms of the number of parts in a given state it can contain. So what you have the preceding stage, you have the subsequent stage. So these are the the full say the containers. So how many full containers we have? So 1, 2, 3, 4, 5. Now this is this container. Suppose there is a the P1. What is P1? P1 is the, now this symbol you use to indicate that it is a withdrawal Kanban. So this container is or say withdrawal Kanban is attached to this particular container. Now the process starts from here. So this container with the withdrawal Kanban attached to it moves to the subsequent stage, and then what you find that you detach the this withdrawal container from the container and put it into the the collection box, and then what you try to do, that means this is a full container. So the full container you use, that means all the items as given in the container, you start using it. okay, for the production purpose, and then full container becomes empty container. And empty container, what you do, that means here this is one particular, say, from the collection box of the Kanban. So you collect one it, and then this is empty container you attach to it, and then what you try to do, that means there will be a swapping over here. That means this particular the Kanban is attached over here, and in the next full container Kanban, what is actually it attached with a production Kanban. So this is detached. This is called basically the swapping, and it goes to the preceding stage, and it is dropped in the collection box over there. That means this is the production Kanban. Now obviously, what happens, this empty container goes over here, and then as per this production Kanban, you start producing, and as soon as the container becomes full, then you attach the production Kanban on it, and then this full container moves to the stacking area. So this is the one cycle is over. So this is the working of a Kanban systems. So as it appears, it is very, very simple and is a repetitive type, and that's why it is well adopted at the shop floor. Is it okay? So all the so when you look at this particular say Kanban system, Kanban production systems, so you start from here, you move over there, then you come back over here, then at the stacking area, then you get back to the preceding stage, and meanwhile you get the production Kanban, and as per the instructions given on the production Kanban, you start producing. So again the empty container becomes the full containers. As soon as it becomes full, so you attach the production Kanban over here, and you send it to the stacking area. So these are the flow sequences in a typical, say, the 2-card the Kanban system. Now there are certain rules to be followed while you operate a Kanban systems. So let me just tell you what are these rules. The first rule says that no withdrawal of parts without a Kanban. Okay, so Kanban is basically treated as authorizations. So unless there is you get the Kanban as attached to a particular, say, the container, you are not supposed to take any action. Subsequent process comes to withdraw parts of the items only when they are needed. That means the pool systems logic. Okay, we have already explained that what is the pool systems, and defective parts should not be sent to the subsequent process. The fourth one is the preceding process should produce only the exact quantity of parts withdrawn by the subsequent process. Now this rule is to be followed meticulously and religiously. The container in subsequent process comes to the preceding process to withdraw the necessary parts in necessary quantities at the necessary time. That means we have defined what is the JIT based system. So these are the points we have already mentioned while we define the JIT systems. If the withdrawals fluctuate in quantity or time, the peak demand decides the inventory levels, equipment and the workers, and hence it is important to smooth or minimize the fluctuations of production. This is also one of the goals of the JIT production system. To what extent you are able to smooth the production. Is it okay? It is necessary to fine tune the production using Kanban. That means you need to stop the process when demand decreases. So that rule you have to follow, or you need to increase the production rate when the demand increases. So this is basically called the fine tuning of the system. Now the next important issue is that how many say the Kanbans you are required to use, and in a given system with a specific the demand rate and all, okay, and with a specific, we need to consider also the safety factor. There is a risk involved, in fact, like because of the stoppage, because of the breakdown of the work systems and all. So the determination of the number of Kanbans is an important issue. So in a Kanban systems, the number of Kanbans in use may represents the amount of WIP inventory in an average. So if you look at the working, or if you study the working of a typical Kanban systems, ultimately you will find that you can define, or you can measure, you can get an idea about the inventory level at a particular point in time in a production system, referring to the number of Kanbans being used. So the number of Kanbans after its determination, considering a number of factors, usually remains fixed. Once you determine, so usually you do not change it frequently. So at periodic interval, obviously you need to review the system, and but otherwise the number remains constant. There are two models, deterministic and probabilistic. So both the models we are going to discuss to determine the number of Kanbans. So let me first tell you what is this deterministic model. The Toyota has proposed and used this model. So the formula used to determine the number of Kanbans is as follows. Like the number of Kanbans, that is Y, should be greater than or equals to capital D into TW plus TP into 1 plus alpha divided by A. Okay, so this is the formula you use in the deterministic model. Now let me explain what are these parameters. The first, Y is the number of Kanbans, capital DT is the demand per unit time. Okay, essentially it may consider it to be the average demand. TW is the waiting time of the Kanban, and TP is the processing time. I have already mentioned about the throughput time. So in the throughput time, so the two the time elements we have considered over here, that is the waiting time and the processing time. And if you add these two, it becomes the lead time. So the alpha is a policy variable indicating of level of external disturbances as assessed subjectively. That means 1 plus alpha is the safety factor. Suppose the value of alpha is 0.4. That means the safety factor will be 1.4. That means what you expect, that 40% of the time, or 40% of the time, the system is affected by some external factors on which you may not have any control. So uncontrollable noise factors. And what is small a? Small a represents the container capacity, usually not more than 10% of daily requirements. So the typical values are say 50, 100, like that. So this is the formula you use. Now in order to control WIP inventory, once determined the number of Kanbans becomes a constant. If the demand increases, the lead time needs to be decreased by taking effective steps. If it is also desirable to reduce the value of alpha to 0 so that the safety factor is 1. That means to what extent you can protect your systems from say the external say the disturbances. So if you can protect it fully, then obviously the value of alpha is 0. And for improving the performance of the Kanban systems, so what is that measure? That means to what extent you are able to minimize the WIP inventory. Reduction in the values of A, alpha and lead time is essential. So with this I conclude this session. So you have come to know how to determine the number of Kanbans, but we have already just considered the deterministic model, and later on in the next lecture session we are going to take up a few numerical examples along with the probabilistic model. Thank you.